This will be a geometry lesson 4.3. Today we're going to discuss isosceles and equilateral triangles. A quick review. An isosceles triangle is a triangle that has two equal sides. And we did discuss last class that if we do have two equal sides in a triangle, what ends up happening is that we have two equal sides, but we also have two equal angles. That's just the way it works in triangles, that if you have two equal sides, you have two equal angles. If you have no equal sides, you have no equal angles. And then if we look at an equilateral triangle, that was a triangle that had all equal sides or three equal sides. We'll also hear the word equilateral when we talk about 4, 5, 6-sided shapes. And what equilateral means is that, hey, all the sides in that shape are congruent. What happened in equilateral triangle then is that, hey, we have all three sides that are congruent. And what also happens there then is, hey, well, if all three sides are congruent, so are all three angles. And that's just the way triangles work. We also discussed real quick, and I mentioned this last class, that if all three angles are equal, they all end up having to be 60 degrees. The reason is there's 180 degrees in here total. That was lesson 4.2. That's 180 degrees split equally among three angles. Well, 180 divided by 3 is 60. Alright, let's talk about the parts of an isosceles triangle first. So if we look at this nice pretty isosceles triangle, we know, and we knew that these two sides would congruent. What we call the two congruent sides in an isosceles triangle, we call those legs. So this would be a leg, and this would be a leg. You can imagine that if you're standing here, your legs are of equal length. Your legs are of equal length, hopefully. If not, you're going to have some back problems. And then what you stand on, this part right here, these are my legs. The part you're standing on, that's the base. Okay, so this part down here would be the base. That's what you're standing on. So we have our two sides. You're also going to hear me say some of these same things next class when we talk about lesson 4.4. Right? So these two sides are called the legs, and then the non-congruent side would be called the base. So you got to be heads up. If this guy's laying this way, and these are my equal sides, these are still my legs, and this would still be my base over here. So it doesn't matter which way it looks at, which way it's laying or which way it's turned. The non-congruent side would be the base, and the congruent sides would be the legs. Right? Now we call this the vertex of the triangle. That would be a vertex. I know there's three vertices here. These are all vertices of the triangle. But this is the vertex of the isosceles triangle, meaning the highest point here. These two guys down here, these two angles are on the base. So here's a surprise right here. We're going to call those the base angles. Alright. Now, you might be able to take a wild guess and get this one, that if these are my legs and these are my congruent sides, then these base angles across from those legs are also congruent. Okay, so we have these two congruent sides here. We have these two congruent angles, and then this guy over here is kind of by itself. We're not sure what that is. So that is discussing the parts. We do have another pretty important part. We're not going to use this chapter, but when we get to chapter 8, start talking about area, we will talk about this distance right here from that vertex straight down at a 90-degree angle to that base, and this part right here would be called the height. Okay, so that's how tall is that triangle. That's the height. It could also be known as the altitude, but we will normally call it the height. Okay, so there's my parts of a triangle. An isosceles triangle, we have our two legs. Those are the equal parts. And then the third part, the non-congruent side, would be called the base. Right? And then the angles that are around the base are called our base angles. Right, so here's the base angles theorem. If we have a nice, pretty isosceles triangle, such as this, and I know for a fact that I measure these and these two guys are congruent, then those base angles are also congruent. So the base angle simply states that if a triangle is isosceles, then the base angles are congruent. That's a nice pretty conditional. So if we have an isosceles triangle, then the base angles are congruent. Now you could go backwards of that too. If you have a triangle and you have base angles that are congruent, you can call this isosceles. Okay? So what it pretty much comes down to, that if we have two congruent sides, we have two congruent angles, and we just mentioned that. Right? Now, equilateral slash equiangular triangles, we talked about this. An equilateral triangle is all of these sides are equal. Now, we really can't call these legs and bases. They're just all sides of the isosceles triangle. So this side would be congruent to this side, which is congruent to this side. Okay, that's equilateral, meaning if this guy over here is 5, so are all these guys right here. Now, the other thing we could have here is that if this is equilateral, we mentioned that it is also equiangular, meaning all those angles are equal. And we just mentioned this, that if we take 180 degrees and we split it equally among three angles, each of these guys has to be 60. Okay, so again, all we did is we took 180 divided equally among three angles, and that means, hey, they're all 60. Okay, that's what's going to happen. No matter how big, this could be 5 inches, 5 yards, 5 miles, no matter what these lengths are, no matter how big or small this triangle gets, if all these sides are equal, all the angles are going to be 60, no matter how big or small. All right? All right, so let's go through some of these problems. Find all the missing angles in the drawing below. So now we could do this a couple ways. If we knew two angles, we could use that triangle sum theorem like last class, add them up, subtract from 180. But we don't know these two. What we do know is that we have two congruent angles. So this is a leg, or sorry, two congruent sides. This is a leg and this is a base. Well, now we have isosceles, so we can use that base angles theorem that states, hey, if you have two equal sides, if you have an isosceles triangle, your base angles, these two angles here, are going to be congruent. Now I'm going to do this. I'm going to draw arrows opposite. So if this guy is 40, then x has to be 40 as well. Okay, so that angle right there would be 40 degrees. Now I don't necessarily need to label x 40 degrees. We could just call it 40. If you put the degree symbol, you're not totally wrong, but we don't need it when we find x equals 40. Well, now we have 40 and 40. That gives me 80. That means that we have 180 minus 80, so y would be 100. Okay. Now that's using that triangle sum theorem that we did last class. All right, let's go to number 2. Number 2, here's a leg, so this is the base right here. That means my base angles are going to be congruent, so x has to be 65. Remember, if we have two equal sides, we have two equal angles. If we have three equal sides, we have three equal angles. And then if we look at y, if this is 65 and 65, we need to add those. 65 plus 65 is 130. We take 180 minus that 130, and we can find y is 50. So that angle up top there is going to be 50. All right, let's go to number 3 and 4. All right, so we look at number 3. We have two equal sides. I know this is 5. That means that this side over here has to be 5, so we might as well go write that in for y. That if this is 5 meters, sorry, that should be meters right there, that this guy here is going to be 5 meters. Okay, now if we look at this triangle, here's my two equal sides. That means that the angles opposite that are going to be congruent. Well, they are. That's 70 and 70. What we're trying to find is this guy over here, the vertex of that. Right? So if we take 70 plus 7, that's 140. We take 180 minus 140. That would mean that this guy would be 40 as well. Okay, so that'd be 70, 70, and 40s. So that'd be a nice, pretty acute isosceles triangle. Now here, 4, there's a couple roads we could take to do this. Some of you might look at this. Some kids might look at this and say, all right, I got it. I think I know the answer. Some of you may actually have to do it algebraically, meaning we could do this with that triangle sum theorem last class. We would take x plus the 110, and we'd say, all right, that's going to be 180. Well, that's 2x, and I'm going to go ahead and subtract that 110. So that's gone, so I have 2x equals 70. Okay, well, if we think of this just logically, well, these guys are going to be equal. So that means I have 180 minus 110. That means I have 70 degrees to split among those two. Well, if you look down here, that's what we're doing. We're going to take 70 degrees and we're going to split it among two angles. So half of 70 is 35. That means that both of these angles in that drawing need to be 35 degrees and 35 degrees. So we could double check ourselves. 35 plus 35 is 70, plus 110 is 180. Same process here. We're still dealing with isosceles triangles. Now, if we look at this triangle number 5, we actually don't know if it has two equal sides. This is 10 and this is x. I don't know what it is. But if we look at the angles, we know for a fact that we have two angles. If we have two angles, we know that this is an isosceles triangle and that this side and this side are congruent to each other. Okay, we know that. That's the base angles theorem. Converse actually is what that is. Alright, so we know right now that if this side is 10, this side over here has to be 10 as well, so x is 10. Alright, now we can use that triangle sum theorem from last class, that if this is 40, this is 40, that's 80. We take 180 minus 80, we know that this is going to be 100. Alright, so that guy's got to be 100. And this guy over here is 10. Now, we actually don't quite have enough information to find this third side quite yet, so we can't really do that. Once we get to chapter 10, after chapter 10, we'll be able to calculate that, but not right now. Alright, let's skip number 6. Let's go on to number 7. So what we have on number 7 is kind of the same thing. I don't know if this is isosceles yet. There's no markings that say, hey, this side is equal to this side. But if we look, this angle is equal to this angle. So if we have two equal angles, we know we have two equal sides, and those sides that are equal are going to be opposite of those angles. So this side equals this side, right? So we can go find x real quick. That I know if this is 20 over here, this side over here has to be 20. Well, there is your equation. That 4x has to equal 20. So we just divide both sides by 4. 4. And x is 5. So that means if I take 4 times 5, that's going to give me 20. That's the way we can work over here. Now for y, we got to look at the triangle sum theorem here, because we have two 45-degree angles. So we have 45 plus 45 is 90. 180 minus 45 is 90. So this guy right here is actually a right angle. So that's a 45, 45, 90 right triangle. Okay. All right. So let's go to number 7. Number 7. Here we go. What I'm going to do is I'm going to find y first. Okay. So if we find y first, this guy's 60, this guy's 60. 60 plus 60 is 120. 180 minus 120 is 60. So this guy over here is 60 degrees. So y must be 60 degrees. And again, if I'm finding y, so I don't necessarily need the degree symbol. Now what we can do up here, because we know we have an equal angular triangle, all these angles are equal, we also know that it's equilateral. What that tells us is that this side is equal to this side, which is equal to this side. So it always went back in the day, for chapter 3 and chapter 2, we were always looking, are they equal, are they 90, are they 180? Well, in this case, these guys are going to be equal. So our equation to solve for x would be 4x minus 11 equals 2x plus 12. You can pause it and solve it if you want, but when we solve that, at the same time I'm going to add 11 that I was subtracting 2x, so then we have 2x equals 16. We divide by 2, and x is 8. Now we can double check ourselves simply by substituting in. 4 times 8 is 32. 32 minus 11 is 21. Do it here. 2 times 8 is 16. 16 plus 5 is 21 as well. Let's jump down now. Again, what we have here on number 9 is we have that these two guys are congruent. So if we have two equal angles in a triangle, we also have equal sides. Those sides are opposites. So this side equals this side. So that means we have 7x plus 5 equals 19. You can go ahead and solve that and find it. Let's go to number 10. If you need to solve number 9, pause it. We'll go to number 10. Number 10, again, if we look at it, I know that this side is equal to this side. So these two guys are my legs. That means that we have two equal sides. We have two equal angles. And those are the guys that are opposite of those sides. Well, now, if this is 3x, what do you think we can call this guy down here? Well, it's got to be the same because those are my base angles, so this guy's 3x as well. Now, I can't start solving x with just these two guys. I needed this third guy to find it. Now, when we do that, we can start adding our angles up. 3x plus 3x, because we have those base angles, plus the vertex angle, which is 4x. And we know when we add all three angles up in a triangle, that guy's going to equal 180 degrees. Okay. So now what we can do is we can solve this. So we go to the left side. 3x plus 3x plus 4x is 10x equals 180. We divide by 10. That's head work right there. You shouldn't reach for your calculator on that one. Divide by 10 is easy. Move decimal place 1 to the left. That would be 18. All right. Let's double check ourselves real quick on this one. We think x is 18. If we substitute in 3 times 18 is 54 degrees. 3 times 18 is 54 degrees. Those two guys should be equal. 4 times 18 is 40 and 32, which is 72. Well, if you add those three angles right there, you end up with 180 degrees. Okay? Now, number 11. Number 11, we know right off the bat, it's isosceles. We have two equal sides. That means that the angles opposite them are congruent. So that means that this angle over here should be 52, and right there's your equation. 5x plus 7 should equal 52. Okay, you can go ahead, pause it, solve it, and I'm going to move on to the next one. Number 12. Now what we know on number 12, if we look at number 12 and 13 and 14 here, we know that we have three equal angles. So this guy, we know right off the bat that this guy is equiangular. Well, if it is equiangular, what else does it tell you about it? Well, it also tells you that it is equilateral. Okay, so we know two things on this: that it's equiangular, but also that it's equilateral. We also know, if we think a little bit, that these angles are going to be 60 degrees. They have to be. Okay, so over here, I'm going to jot that in, and that's going to help us here in a second. Okay, so now if we look at this, we know this is equiangular, which means it's also equilateral, which means this side equals this side, which equals this side. There's your equation. These two guys, sorry, this should be an x right here. These two guys should be equal, so we can go 4x plus 2 equals 8x minus 10. And again, we can just subtract 4x, subtract 4x. I'm going to solve this one real quick. And I'm going to add 10. So we get 12 equals 4x, x equals 3. All right. Now the next one right here, we know this is equiangular. We also know that it's equilateral, but I don't know any of the sides, so that really doesn't tell me anything. But we do know that this guy is 4x, but it should also be 60. Now we've always done, hey, are they equal, are they 90, are they 180? Here's a case, 4x equals 60 instead of 90, 180, or something else. All right, so if we look at this, quick solve, divide by 4, and I always like to mention this, the easy way to divide by 4 is divide by 2 twice. 60 divided by 2, half of 60 is 30, half of 30 is 15, so that's 15. Now 15, there's two ways we can do this. We can look at it two ways. I'm going to do it this way. I'm going to show you the long way, and then I'll just do it the quick way. If we look at this guy, we know that it is equilateral. Now, since we know it's equilateral, we actually didn't need to know that to do this problem. If we would use that triangle sum theorem, we could go 10x plus 10x plus 10x. Now, some of you might be going, well, why don't you just do it this way? Hold on. We can solve it this way and go 30x equals 180. And we could do that. That's good, great, grand. Now, here's a slightly quicker way. Because this is equilateral, it's also equiangular. What does that tell me about every single one of these angles? Well, that it is 60 degrees. Okay. Well, here's a slightly easier equation to use. That 10x, that should be 60 degrees. So if you did this, 10x equals 60 degrees, divide by 10. That's calculator work. That's not head work. You would get x equals 6. Okay. Now, if you solve this, you would divide by 30. Well, look, 0 cancels out. 18 divided by 3 is 6. So either way you're going to go, you're going to get the same answer. All right. Again, let's move on to number 12. We could do this two different ways, so we're going to jump back to number 12. We can do this two ways. It's equilateral, which means it tells us a couple different things. It's also equiangular. All of these are equal. Okay, so there's one equation. We know that that 5x should equal that 3x plus 24. That's fine and dandy. We can do that. Here's another equation. Because it's equiangular, we also know that it's 60 degrees all the way around the horn. So here's another equation. We could do that. 5x equals 60. We could also do 3x plus 24 equals 60. Either way you go, you're going to get the same answer. You divide by 5, you divide by 5. X is 12 no matter what way you go. Okay? And don't worry about that y equals. Now this guy right here, number 16, this is what we did last class. This is not isosceles. Okay? Because we don't know if we have all equal sides or all equal angles, or if we have two equal sides. All we have is angles. So to do this one, we just take the angles, 5x plus 10, plus 2x plus 10, plus that 90, don't forget that 90, equals 180. Now we combine everything on the left side, that's 7x, that's 10, 20, 110, plus 110 equals 180. Subtract 110, you get 7x equals 70. Divide by 7, x is 10. Okay, so that's a little review. So your homework for today will be just do the Math Excel. Our homework for the day was the Math Excel 4.3 dealing with isosceles and equilateral triangles. If you have any questions, please stop by and see me during seminar before or after school. Good luck, and we will see you next class.